Hello, and a warm welcome to lesson number 1 in this series for beginning STEAM teachers, where we will learn how to program a cute mini robot car using the BBC Microbit and Microsoft's MakeCode. This course is at the novice level, so no prior knowledge of programming or microcontrollers is necessary. We call this level the Scout level. My name is Peter, I am the founder of Educomondo, and I am a certified STEM instructor and content creator. Let's get started and take a look at the goals of today's project. Today is all about exploring our new environment and getting acquainted with our new tools. First of all, we are going to have a closer look why we have chosen to combine the BBC Microbit with a robot car. Next, we will assemble the DeskPi micro robot from the company GeekPi. And we will do some basic programming with MakeCode blocks on the BBC Microbit. Let's start with some background information why we have chosen to create projects including a mini robot car. Combining a BBC Microbit with a robot car offers significant advantages for teaching STEAM projects compared to simply programming the microbit in isolation. And here are 3 key reasons. First of all, it provides tangible and engaging real-world applications. When a microbit controls a robot car, your code directly translates into physical movement and action. This tangible output makes learning more engaging and exciting, instead of simply seeing results on a screen. Secondly, it fosters interdisciplinary learning and problem solving. Integrating a microbit with a robot car naturally blends multiple STEAM disciplines. Students need to apply science concepts like physics, for instance motion or forces. They need to apply technology skills in programming and electronics, engineering principles in design and construction, art through creative customization of the car's appearance or behavior, and math for calculations related to speed, distance, and angles. And thirdly, it enhances understanding of sensors and control systems around us. Robot cars incorporate various sensors, for instance light, ultrasonic, infrared, line following, and by programming the microbit to interact with these sensors, you gain a practical understanding of how sensors collect data from the environment and how this data can be used to control the robot's behavior. This provides a foundational understanding of control systems which are prevalent in many technologies around us. Let's now have a walk around of the BBC Microbit, the heart of our projects. The first microbit was released in 2014, so it's been around for quite some time, and it has been very popular around the globe with educational institutions. Actually, the roots go back to the early 1980s when the BBC created a computer called the BBC Micro. These devices aim to bring the public and students closer to programming and computing. The microbit is also different from other microcontrollers as it contains all sensors and LEDs embedded on the print. It comes with a typical microbit 5x5 LED display, a sensor that measures acceleration in 3 axes, along X, Y, and Z, which can be used to detect movement, shaking, and orientation. There is a sensor that measures the Earth's magnetic field, and this can be used to determine the magnetic north. There is a sensor that measures the ambient temperature. There is a sensor that measures the light intensity, which can be used to detect light levels, create light-activated devices, measure brightness, or create a light-following robot. There are some buttons, button A and button B, so 2 physical buttons that can be pressed to trigger events or input data. And there is also a built-in radio module that allows the microbit to communicate wirelessly with other microbits or compatible devices. The pinout diagram is also different from other microcontrollers. All 25 pins are located at the bottom edge. There are 5 large pins and 20 small pins. I suggest that you print this out for use in your classroom. I also want to mention that there is a vibrant user community in case you run into problems. You can always check for the latest news on the BBC Microbit website that contains tons of materials to inspire your own projects. Let's now take a look at the software. By far the easiest way to program the microbit is by using Microsoft's MakeCode. This block programming environment is quite similar to Scratch, yet it has been optimized to work specifically with microcontrollers like the BBC Microbit and specifically using sensors and actuators. It is web-based, so you can use different operating systems and your projects are automatically stored in the cloud. You only need to create an account and you're ready to start with your first project. Finally, let's take a look at the real star of our projects, the micro robot car from GeekPy. There are a couple of reasons why we have chosen this robot car, specifically taking the typical classroom environment into account. First of all, it comes almost completely assembled. While with other brands, you have to fiddle with small screws to assemble motors, the battery housing, connect cables, and so on, this GeekPy model comes as good as finished out of the box. Unique is that it comes with a small OLED display, which is very handy to display any feedback that you want to show on this display. And quite rare these days, the box contains printed operating instructions with examples. So no need to visit a website or document repository to download manuals. From a construction perspective, the wheels are large and made of some soft rubber, which make the car more robust when falling from a desk in your classroom. And that will happen sooner or later. I also like that the batteries are located underneath the robot car and that there is a large on-off switch that is easily accessible in case of an emergency. It has the most common sensors on board, like 2 light sensors, an active infrared sensor or grayscale sensor, an infrared remote receiver, a sound sensor, and of course the ultrasonic sensor. It also features 4 RGB LEDs. And each time the pin number is clearly printed on the board so that you don't have to consult the pinout diagram all the time. A negative is that it has limited extension ports, less than some other brands, and that there is no easy way to expand the robot car with Lego-based constructions, like for instance a servo-operated gripper arm. There are 4 holes in the chassis plate for some struts, but I found these quite difficult to access. A final word of caution: with most of these small robots, the microbit is not included unless it is specifically mentioned, so make sure that you check this out. Now it's time to bring all of the pieces together. The microbit clicks into this slot, and make sure that the front of the microbit, so where the 5x5 LED array is, faces forward. Go to the website makecode.microbit.org and create an account or log in with your Microsoft credential, or pick one of the other options. This is a totally free platform, so no need to pull out your credit card. Connect the microbit, and this should automatically be detected by the platform. If it is the first time that you are using the microbit, you may be asked to pair it with your computer. Just follow the step-by-step guidance. Let's write our first small program, just to test whether the microbit is reacting. Click on New Project, and you will enter the programming environment. I know this can be a bit overwhelming the first time because there are so many options. We'll be explaining and using most of them during our project. For now, we just want to check the display by showing a heart. I go to Basic and I select the Show Image and drag this to the Forever block, where I put it in the slot that has a similar shape. It's just like a puzzle, and you can see that the shape fits snugly into the other shape. That's it. Download the code, and you can see that both on the virtual and on the physical microbit, a nice heart is displayed. It looks like the microbit is functioning, and we are ready to take the next steps. This closes our first lesson, in which we selected a suitable micro-robot to offer affordable robotic lessons in our classroom. We introduced the BBC microbit and checked it by running a small program. In our next lesson, we'll explore more of the initial programming and get more acquainted with the functionality of the microbit. Bye bye for now.